Okie dokie, let's get started with this. So, first things first, let's think about the actual probability, how probability works. So, let's have a look at this. When you've got probability, you're looking at how likely it is that something's going to happen. Basically, in this case, we've got a deck of 8 cards, and then we've got a deck of 8 cards again, but unlike the other deck, this is made up of 4 pairs of cards. So we can look at the probabilities for each of those, and that'll start to give us an idea of what we need to think about when looking at Hearthstone. So, 8 unique cards. What is the probability of drawing one of those cards? So, let's say we've got card A, B, C, D, E, F, G, and H. Now the probability of drawing any one of these 8 cards would be 1 in 8. That makes sense. You've got 1 chance in 8 of drawing a specific card when you've got 8 cards in total. And then, once you've drawn that, let's say we draw A first. Then, once that happens, you've now got a 1 in 7 chance. Because you've now got 7 cards left, you've got a 1 in 7 chance of drawing any particular card. And that just keeps going. So the general idea is number of desired outcome all divided by total possible outcomes. So in this case, a desired outcome is whichever card it is that you're wanting, and then the total possible number of outcomes is how many cards are left. What you can then do is you then look at the other system. So now in this case, we've got A, B, B, C, C, D, D. So we've got 4 pairs of cards. Now in this case, let's say we wanted to draw A. In this case, the number of the desired outcome, there are 2 possible chances of getting that desired outcome. So we've got 2, and then on the bottom, we've still got those 8 cards. So, once again, it's 8. Now 2 over 8 can nice and easily go to a quarter. Therefore, where in the first instance you had a 1/8 chance of drawing one of those 8 unique cards, in this case you've got a 1/4 chance. And this is where things get a bit different. So let's say we draw A. So now, then for the next round of drawing, if we still wanted to draw A again, it becomes different, because now there is only 1 chance of getting that, and there are 7 cards. However, for the other ones, there are still 2 of them, and so it remains 2 on the top, but the bottom becomes 7. From this, we can start, using this logic, we can start to think about, okay, what's the probability of which card being drawn, and all of that kind of stuff. So if we switch back to Hearthstone, we can start to have a look at this stuff. So we have 8 cards in the deck right now. That means of any of the cards, I have a 1 in 8 chance of drawing what's in there. So we'll finish this game, then we'll move on to the next one, And while we've got the deck all up on the side, we'll start to talk about what are the probabilities of various different things and start thinking about how they work together. Okay? So, in this case, let's go with that one. And yeah, why not? So what I'm currently playing through is one of the dungeon runs, so back during the Kobolds and Catacombs expansion. The dungeon runs are just quite nice because they start off with quite small decks and then we can work from there. So we pull this guy in and we do that, we do that. And as you can see in the earlier levels, the thinking about strategy isn't that quite so much. Whereas as you get higher up, well, as you get later on in the dungeon run, then you need to start thinking about it a bit more. So, we can pull that one out, pull that one out, do that, and then we can do that. There we go. Now we can do that one. So I did get rid of most of my units, but it's not too much of an issue. There we are, because next turn we'll be able to use the hero power, get rid of him. There we go. So technically right now I have a 100% chance of success if we start thinking about percentages and all of that stuff. There we go. So now we have a choice. Now each one of these sets of cards has various synergies, various ways that things can work together. For example, the quest casts 6 spells that didn't start in your deck. So you'll need to have a look and figure out, is the probability of being able to get that many spells that didn't start in the deck, is that a reasonable probability? So let's have a look at what cards we've got. So there's a minion, there's a spell, minion, spell, minion, minion, spell, minion, spell, minion. So grand total, we've got 14 cards, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. However, the Robe of the Magi, that's a passive one, so it doesn't actually count towards the grand total because you're never going to draw it. So, do we have any spells at all that are going to allow us to create a new spell? No, we don't. Therefore, Open the Waygate isn't so good unless we have a look at the other ones. So, what you also get, Spellslinger, that adds 1 spell, and then Kabbalist Tome adds 3 spells. Now, that means we can only at most get 4. So to begin with, this quest isn't very useful. There is a decent chance later on that this kind of thing may pop up again, but there's no guarantee. So let's look at the other ones. We've got a defense spell system. So in this case, there aren't really any synergies, it's just simply board control. So if we find that the synergies aren't worth it in the other ones, this is a good backup option. Then we've got Deck of Wonders, Dragoncaller Alana, and then another Dragoncaller Alana. Now, do we have that many spells that cost 5 or more? We've only actually got the 1. So again, the synergies this early on in the game aren't great. Thing is, here, so we produce 4 spells here. We need 6, so that means we only need to get 2 more. At this point, we might as well go with that. That'll bring our total number of cards up to 16 cards if we're excluding the Robe of the Magi. So that means that any one of the cards we have, because there are no duplicates at this point, any one of the cards has a 1 in 16 chance of getting drawn. So, given that we draw 3 cards at the beginning, let's switch back to here. So we can have 3 cards at the beginning. Three cards drawn and 16 cards total. So that means, let's say the first card we draw has a 1 in 16 chance, but that then means one of these has disappeared. So that means that then the next one we have is a 1 in 15 chance, and then the last one is a 1 in 14 chance. Now, because these are independent events, so the only effect is just that bottom where the different numbers are drawn, what we can do is we can actually add these probabilities together to give us the total probability of drawing any one card. So, admittedly, it's a little bit messy with these ones just because of the numbers. So, it's going to be 1 plus 1 plus 1. Sorry. We're going to end up getting 15 times 14 over 16 times 15 times 14. The reason why this is okay is because if you multiply anything by 1, nothing changes, and so we've multiplied this here by 15 times 14 divided by 15 times 14, which is the same. Then we can add that to 16 times 14 over 16 times 15 times 14, and then the same again for the last one. You'll notice on the top is basically whichever one is missing from the bottom. Sorry, not missing, whichever one is present on the bottom originally. So then we have, that's 16 times 15 over 16 times 15 times 14. So let's first get these, the initial ones going. So what we can do nice and easily without even needing a calculator is we can just use long multiplication. So 4 times 5 is going to be 20, so we carry the 2. 4 times 1 is 4, but then plus the 2 gives us the 60. Now we're moving to the next column, so we just have to multiply all that by 10, so putting a 0 here. 1 times 5 is 5, and 1 times 1 is 1. And then we can add those together. So 0 plus 0 is 0, 5 plus 6 is 11, so we carry the 1, and then 1 plus 1 is 2. So that means we've got 210 on the top for that first one. Then we go 16 times 14 for the next one. So 4 times 6 is 24. It's going to go carry the 2 up there. 4 times 1 again, so we end up getting that 6, which makes sense because if 15 times 14 is this, 16 times 14 means we just add another 14. So again, we add the 0 in here, we end up getting 6 because 1 times 6, and then 1 times 1. And so then we get 4, and then 6 plus 6 is 2, carry the 1, and then we get that. So as you can see there, we've just added 14 to that. So on the top here, we have 224. And then the last one, again, we could probably figure it out just by adding stuff together, but we might as well go through the correct process. So 16 times 15, this one should be 16 more because we've got one more lot of 16s. But 5 times 6 is 30, so 0, and then carry the 3. And 5 times 1 is 5 plus the 3 is 80. And we put the 0 down, and we have 1 times 6 and 1 times 1. So we put that through, so 0 plus 0 is 0, 6 plus 8 is 14, so we carry the 1, and we have that, which is 16 plus the last one. So, what we can, now that we've got the top ones, we can either do long multiplication with all 3 of these, or we can just take any one of these and multiply it by whatever's missing. So I'm going to take the 240, because it's a nice number, and multiply that by the 14, because 240 was 15 times 16, therefore missing the 14. So, if we do that, we've got 4 times 0 is 0, 4 times 4 is 16, so we carry the 1, 4 times 2 is 8, plus the 1 is 9. And we put the 0 down, and we've got 1 times 0 is 0, 1 times 4 is 4, and 1 times 2 is 2. Nice and easy. Now we add it together, 0 plus 0 is 0, 6 plus 0 is 6, 9 plus 4 is 13, carry the 1, 2 plus 1 is 3. So that means that each one of these ends up being all over 3,360. Now this probably looks absolutely horrendous and terrible right now, but hopefully it'll become a little bit nicer. So if we add together the 240, the 224, and the 210 up here, so looks like long multiplication, but this is going to be long addition instead, so basically what we did underneath the multiplication. So 0 plus 4 plus 0 is 4, 1 plus 2 plus 4 is 7, and 2 plus 2 plus 2 is 6. So what we end up getting is 674 divided by 3,360. Now this looks probably horribly terrible, but what we can do to make our life simpler is we can sort of estimate stuff. So let's say we rearrange this to be, what's a good one? Let's say this is approximately equal to, that's what the sort of curvy equals. Let's say that's approximately equal to 3,500, and then say the top is approximately equal to 700. That makes our lives a lot easier, because that becomes 7 over 35, which is just 1/5. Now, if you give me a moment, I'll just use a calculator to get the exact number, and it should be close to 1/5 or 20%. So 674 divided by 3360. Yeah, so the exact value of what that is equal to is 0.2006 if we go to 4 decimal places, or 4 significant figures. So essentially saying that it's a 20% chance is about right. So we have a 20% chance of drawing any one of the cards in the deck. So if we switch back to Hearthstone, we can use that knowledge. So if we have, let's go ahead and we'll select the quest. We'll go with that one for now. And so we now have a 20% chance of picking any one of these cards. So a 20% chance of picking that, 20% chance of that, 20% of that, 20% of that. So we have a pretty decent chance, a 1 in 5 chance of getting any one card, and the fact that we have 4 1-cost cards means that we're probably going to get a 1-cost. Admittedly, the quest will come in and be drawn straight away just due to the mechanics of Hearthstone, but it's not going to be useful to us this game, as we discussed earlier. So we actually only have 3, but that's still 3/5 of a chance of getting a 1-cost card, which is about 60% chance of getting a 1-cost card that'll be of some use to us. So let's go in, let's play the game, and we'll see how that goes. I will note this is also not including the possibility of doing a redraw. We can maybe look at that after this game, because that does change things up a little bit. So, yep, so we've got a 1-cost card here, as well as the Open the Way gate. Now, if I get rid of that, then what we'll end up getting is what we thought we'd get. So we may even get another 1-cost. Now, we got another 2-cost, but still, the idea is there. It was quite likely that we would get a 1-cost card that we'd be able to play. So let's put that down. There we go. Let's see, so he has no other cards. So now we're down to 11 cards. That means any one of the cards in the deck. So we had 4 1-cost cards, and we've drawn one of those. One of them is the quest, which we don't need to worry about. So we've got 2 cards in there that are 1-cost. So that means we've got a 2 in 11 chance of drawing a 1-cost card. In this case, what I'm going to do, because we already have things that work with it, is I'm going to bring in the Sorcerer's Apprentice. We'll do an attack, and hopefully the other guy doesn't have something to counter that with. Okie dokie. So he didn't have anything to counter it with, so what we can do is we can go ahead. I'm not too fussed about this guy. We can do that, and then we can do a nice bit of damage straight to his face. And there we are. For these early guys, and this isn't probability so much, this is just experience talking, for these early guys, it's a pretty decent idea to just go straight for the face for the most part, because now I've got the fireball for 9 damage, I win. There we go. As I said, early games, strategy's not quite so big. Later on it becomes a lot bigger. So that's another game done. Here again we have to think about what works with what. So the Blade of Quel'Dalar, that's one of them which, if you manage to get the hilt as well, you get something really powerful. However, that's assuming that you actually get it, and there's only one other chance to get a treasure, so you have to be really lucky. In this case, probability's not really in our favour, because it's 1 in however many treasures there are, and I'm pretty sure there's more than 8. Well, there's a 3 in however many treasures there are, but there's more than 8. There's more. I think there's more than 10 different treasures. So it's starting to get less probable that you'd be getting it. The take control of an enemy minion, that can be useful. However, we have to remember, because it adds it to the dungeon deck, that does change what the probabilities for the cards are. So when choosing to use it, we can't just simply go with whatever seems like a good idea. We have to actually think about the long-term effects on that. We could also go with the Orb of Destruction. However, I'm going to go with the Amulet of Domination just because it goes with the whole probability question that we're looking at. It makes things a bit more interesting. So we'll select that one. Now, we still want to be looking for stuff that can work with the quest. So if there is anything that can put more spells into the deck, we should take it. So here, that's not going to give it to us unless the minion that dies is the Spell Slinger, which that would then bring us up to the 6, which is required for the Waygate. Frozen Clone could help if there's an opponent who plays a card that fits it, but again, it's very particular and you have to get it just right. Then there's Mirror Entity. After your opponent plays a minion, summon a copy. This will only give us a new spell if there's something with a Death Rattle that does that, or if maybe there's an Inspire, so when you use the hero power you get it. Duplicate, so same again what we said before. Molten Reflection, again similar to Mirror Entity, it's only useful if it's got a Death Rattle or an Inspire or something like that. Molten Giant, personally I avoid because I try to avoid losing health. However, it can be a useful one to go with. Here, this one, Frost, that's all control, so doesn't create a spell, doesn't create a spell, and doesn't create a spell. What I'm going to do, especially since we have the Sorcerer's Apprentice, I'm going to go for the Secrets one to get those spells that may help. Even though it's not a guarantee that it'll give us more spells that didn't start in our deck, there's a higher chance because there are 3 cards that could potentially give us more spells, whereas here there's 1 card, well, 2 cards that can potentially give us more spells, and here there are none. So we'll go with the 3 that give us a chance, because if there are more more of the desired outcome, that means that it's more probable, assuming that you've still got the same number of the total outcomes. So we'll go with that one. So now that we're getting to the middle, this is where we do need to start thinking about these things. So this guy, he buffs his minions. Thankfully we do have that spell damage increase, which means that we can do a lot more damage if necessary. Now if we look at it, so ignoring this one, we've got 21 minus 1, 20 cards. So it's still those 3 1 costs. So if we switch back to where we were figuring it out, we've got those 3 1 costs, 3 times 1 cost, and 20 cards total. Now because of the quest, we're actually only going to get 2 cards that aren't the quest, so we can simplify this a little bit from the last time. So that means we've got a 1 in 20 chance of getting a 1 cost card, and then a 1 in 19 chance, because one of the cards is gone. Because of, if we ignore the quest, we can even change it to 1 over 19 to begin with, because the quest has already been drawn, and then a 1 over 18 here. So now again, just quickly go through, do 18 times 19, so 9 times 8, 80 minus 8 is 72, so 2, carry the 7, 9 times 1 is 9, plus 7 is 16, and we've got the 0, 1 times 8 is 8, and 1 times 1 is 1, add that together, you've got 2, 8 plus 6 is 14, so 4, and carry the 1, and then we have that, so 342. And in this case, because it's only 2 things, we just have 18 on the top over here, and then 19 on the top over here. So we end up getting 18 plus 19 all over 342, which then goes to 18 plus 19, 9 plus 8 is 17, plus the 1, that's 37, all over 342. Now again, we can go, okay, let's sort of just try and simplify this a little bit just to make our lives easier. You want to change the numbers as little as possible. That's going to be approximately, yeah, let's say it's going to be 40 over 340. Means we've changed the numbers very, very little. We've just rounded them. And so 340, so 40 goes into 200 5 times. That means that it goes into 102.5 times, and it goes into 40 once. So that means we can add these numbers together, because 200 plus 100 plus 40 is that 340. So we end up getting 8.5. So we've got, goes to 8.5 it's going to be 1 over 8.5. Now, because we don't want decimals with our fractions, we just multiply the bottom by 2, because 0.5 times 2 becomes 1. So we end up getting 1 over 17, because 8 times 2 is 16, plus the 1 is 17. So 1 over 17, it's a little bit of a messy number. I mean, it's close to 1 over 20 again, but we don't want to be generalizing quite like that. For a number like this, like, yes, it's close to the 20%, but I'll just use a calculator to figure that out. 1 divided by 17, that is 1/17 is equal to 0.059. So it does go a little bit beyond the 20%. Now we figure out what that original number definitely was going to be. And we go 37 divided by 342. So in this case, our estimates have been a little bit off, because that ends up being 0.1081. So we were a little bit off with those estimates. Let's just check to make sure that I got the numbers right. Oh no, sorry, that's where I went wrong. So that should have been a 2 up there, because we multiplied the bottom by the 2, therefore the top goes by 2. So that becomes that times 2, which actually equals 0.1176, which is comparable to what it actually is. So in this case, we've got a 10% chance of drawing a 1-cost card. What that suggests is we do need to start thinking with the next draw to start getting those more of those 1-cost cards, those lower cost cards. Yeah, so we double this because there are two 1-costs that no, 3 1-costs that are relevant. So yeah, we have 30% chance, but yeah, we should still be starting to think about getting more of those 1-cost cards, so that we have something to do in that first instance. So let's have a go. Let's see how this goes. Ideally, I'll end this run with a success. I can't guarantee it, but we can hope. Okay, so remember, 30% chance of actually drawing a 1-cost other than the quest. So as we can see here, that's happened. So we could get rid of both of these cards here, but because there's a chance that Open the Way Gate will be useful this time, I'm going to stick with it, and these are 2-cost cards, so we're all good with that. We can do those next time. So let's see how that goes. There we are. Okay. So now 16, and we have 3 cards which are 1 cost. However, in this case, 1 cost, not as useful now. But yeah, if we have 3, that means next turn we have a 20% chance of drawing a 1 cost card. What are we going to do? This is a wee bit bothersome. So because this guy has the buffing minions, I'm going to do my best to make sure he has as fewer minions as possible. Because if he has more minions, that means there's more that he can buff. Still not very good. So, I'll do that. So by now it would have been quite handy if we had drawn a 1 cost, which another 1 cost card is a 3 in 14 chance, so more than 33% chance of drawing something that's useful. So what we can do now, we can do that one, and then what's the death rattle? They've summoned a basic... I'm going to do this, because then it starts to bring that guy down, because that guy is reasonably powerful. However, I think this guy's going to use his hero power now. Yep. This is why I wanted the board to stay as clear as possible. Okay. So again, not a 1 cost card, but now it's a 3 in 12, which is 1/4. Sorry, last time I said a third, I was wrong. It was supposed to be 20%. So now it's a 1/4 chance of getting that 1 cost, which, given the number of cards in our hand, a 1 cost would be nice just to fill out that that mana curve. Okay. Whatever do we do here? I'm going to use this guy. Hopefully we get a decent card. I'm not going to do the stats for spells. Oh, that wasn't... Nope. So what I'm going to do now, purely because it's causing me the most... Oh, no. Because that's the thing. Then it creates junk, and I don't have Murlocs. And on top of that, Mage, not a real Murloc-y kind of bunch. So what I'm going to do instead... yeah, we'll do that. I may come to regret this, and if so, this will be over much quicker than I thought. Yeah, he's going to hero power at some point as well. Oh no. This may not end as well as I thought it would. Oh, yep, I've lost. There we go. So, didn't quite end how I thought, but the probabilities and all of that was still there. And now you guys know how to figure out what those probabilities are. Do I do that or don't I? No. Yeah. So we'll talk a bit more about how it all works. So we've got all of the stuff that we've been thinking about. Now this can apply to literally any card game. So let's say you had a deck of cards and you're playing poker, blackjack, literally any card game with your mates. Let's say you... so within your classic deck of cards, there are 52 cards. If we aren't using the Joker, which most of them don't, no Jokers. Therefore, drawing any one card is a 1 in 52 chance. The thing is, with stuff like poker, maybe you want 4 of a kind. So in that case, you'd be looking at 1 in 52, and this is assuming no one else is playing. 1 in 52 plus 1 in 50. No, this, because these are dependent events, so one depends upon the other. we've got a few different things that this ends up being. So there, let's say 4 of a kind we're going for, so we've got 4 and 52. Then assuming we don't get it on the first card, times 4 and 51 times 4 in 50. No, that won't work, because once you get, so I'm assuming 5 card draw. The only possibilities wherein you can succeed, so let's do a probability tree for this one. So there's draw a not useful card, so N, or draw a useful one, U. And we're going for the 4 of a kind, so after the N you could get another not useful one, at which point that probability tree ends, because if it's 5 card draw and 2 of them are not useful, then that means you can't get 4 of a kind. So not useful, then you could get useful off of that first one. Then we go N, and then we go U. So we end up getting, so a really good one would be all U's, but then obviously for 4 card draw we can't get them all, so then we have the N. And so then we can have an N there. And with all of these, basically, as soon as you have more than one N, it all falls apart. So we can even sort of break off that, because that's not a successful outcome. So then we have U, U, and U, and then we have an N, a U, a U, and then here we have an N, and then a U. So now we have all the possible options that we have. So we have an N, N, U, 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 U. We have U, N, U, 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 and then U, U, N, U, 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 N, U, and U, 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 N. Those are all the possible outcomes. I'm not going to do all of them, but we can just quickly do one, and then you just add all of them together. So let's say we go with this one. We have, so if there are 4 cards that are useful, 52 minus 4 is the number of cards that aren't useful, so that's 48. So we have 48 over 52 times, now we want useful, so we've got 4 over 51, and we've drawn one of the useful cards, so now that drops down to 3 over 50, and then we've drawn another of the useful cards, so it's 2 over 49, and then multiplied by 1 over 48. We can do long multiplication for all of this, but to save a bit of time, I will just plug it into the old calculator. So remember, when you multiply fractions, the top is multiplied by the top and the bottom is multiplied by the bottom. So we end up having 48 times 4 times 3 times 2. We don't really have to worry about the 1, because times 1 is whatever it originally was. So we end up getting 1, 1, 5, 2 over, and now we want 52 times 51 times 50 times 49 times 48, which becomes a very large number, 311875200, which that number, just as a percentage, is going to be very, very small. So 1152 divided by 311875200. Yeah, so what the calculator's given me is 3.69 times 10 to the negative 6. So that means that this decimal place has been moved 6 times, so we end up going, okay, 0.1, 2, 3, 4, 5, 6, 6, 9, which if we think about percentages usually, that's where they start. So that means we've got a 0.000, let's just round it, 4% chance of getting that particular one. So if all the other ones had the same probability, which they will end up having the same probability because while the numbers will be in a different order, it'll all be the same numbers multiplied together. Therefore, when you add it together, there's 5 possible ways that can go. So that times 5, 4 times 5 is 20, so it ends up being 0.002% chance that in 5-card draw, you would draw 4 of a kind. So, I mean, that's always fun. But yeah, you can apply this to any sort of card game. And the thing is, the professional Hearthstone players, they all use this kind of logic when they're thinking about it. So let's say they're worried that they're not going to win, but there's one particular card in their deck that could save them. They're able to go, well, okay, this card will save me. Is the probability quite high that it's going to do it, or do I just need to be really careful and try and survive until it comes out? So I'm just going to, in the Twitch chat, I'm just going to put in the Discord server for all of this. So if you have any questions, if you have any ideas for lessons, topics, video games that could be used for teaching something, feel free to mention it. I'll also just pop it up on the screen as well. This should work. Yeah. So if you go to that, that's the Discord server. Feel free to pop in, suggest stuff, give feedback. I put in little challenges. So for example, the one that can be for this one is do some probability work on your favorite card game, or even dice games work as well, things like that, even just board games. Try and have a go at figuring some of that stuff out. But otherwise, everyone do take care of yourselves in this time, as around the world we really do need to, and I'll see you next time. Goodbye.